Algebra 1, Model 4, Lesson 9, Graphing Quadratic Functions from Factored Form. Okay? So you have factored form there. What's that A out front? What's that be talking about? A little A out front. Alphabets is equal to A times. What's that? We see the factors there. X minus M, X minus N. But what's that A? What does the A mean? It means you factor something out in the very beginning, right? If it all had a 8 as the greatest common factor, you would have factored that 8 out. Okay? That's what A is there. All right, so let's look at it. It says graph the following functions and identify the key features of the graph. So we have t is equal to x, or not t is equal to, t of x is equal to x squared plus 8x minus 20. So let's go ahead and put that. There's no common factor, so let's go ahead and just put it in factored form. We would have x, the negative 20 tells me that my signs are going to be different. And I can say positive 10, negative 2, because that'll be a negative 20. And if I combine those, that'd be a positive 8x. Everybody agree? Now, when we started going over these polynomials, I told you we're going to solve these and we're going to get them in factored form. And then when you solve those can be called a lot of different things. They're called zeros, they're called x's, they're called roots, there's called a lot of different things. So let's look at them. If we go ahead and solve it completely, we would have what? X equals negative 10 and x equals 2. Everybody agree with that? Everybody understand how we got that? If we set those equal, x plus 10 equal to 0, we would move the 10 to the other side, making it a negative 10. Right? So, those two factors are your x's. Now, what does that mean? Think, we set it equal to 0, and that's what our x equals. So, when x is negative 10, what does that equal? If I was to plug negative 10 or 2, let's plug 2 in. If I plug 2 into the formula, 2 squared plus 8 times 2 minus 20. Well, that's 4 plus 16 minus 20. That's 0. T of x equals 0. So what does that tell me? At 2, 0, I have a point on the parabola, because a quadratic is going to give me a parabola. Okay? So that means negative 10, 0 is another point on the parabola. Okay? So let's graph that. Ooh. Let's see here. Let me see if I can draw some decent lines here. Alright, if I click here. Oh, that's a pretty one. See that? See that? Look how pretty. Ain't it pretty now? Just look at it. You know what I say when I see something like that? Just look at it. Alright. So we need negative 10s. Let's count over negative 10. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0. Actually, let's go with a different color. Can I do that? Sure. Let's make it Christmas. Alright. There's negative 10. And we also need what, 2? Ooh, I about messed up. That didn't make it big enough over here, did I? So there's 10 and 2. Negative 10 and 2. Now, how are we going to find something else? There's another key point that we know for sure right now. Faith. You probably don't know the vertex right now. Well, that's going to run through your vertex, right? So we don't know that. There's one thing that we know by looking at that trinomial, that polynomial. We know what the what is. Okay. There you go. What is the y-intercept? If we plug in 0 for x, what do we get? Guys, can we all look at the screen and tell me if I plug in 0 for x, what do I get? Look at your screen. So you're telling me if I plug in 0 squared plus 8 times 0 minus 20, what would I get? Negative 20. That is the y-intercept. So if I do that, I may not have enough room down through here. Let me have to go with, let's go with these counting like 2 each, maybe 2, 4, 6, 8. Yeah, we can do that. That's going to be negative 20. That's the y-intercept. Okay. Does that look right? It could be. We don't know. It could be, though. Which means well, actually, let's do it different. I'm going to do it by, let's do it by 5s. Let's not do it by 5s. Let's do it by 4s. 4, 8, 12, 16. Oh no, I don't want to do that. 4, 8, 12, 16, 20. That would be negative 20 there. Okay. I think that'll work out better. All right. So now we have our x's. How do we get our x's? Factored form, set it equal to 0. Guys, I would write this down. If you're not, I'm sure y'all are staring at me blankly, don't have a clue what's going on. How do we find our x-intercepts? Factored form, set each factor equal to 0. Okay? When it's in factor form, we set them equal to 0. Whatever x equals, that's our x-intercepts. X equals, that's our x-intercept. Now remember, we've always talked about f of x is equal to what? What? F of x is y. It's y. So if we plug in 0 for x on our graph, think about it. 0's x. What is that going to give us? No, if we plug in 0 for x, what does that give us? If we don't move off of the y-axis, if we stay on 0, that's got to give us the y-intercept. So if we plug in 0 for x, we get the y-intercept. Write that down. You need to know that. Plug in 0 for x, get the y-intercept. It should be as easy as you looking at the very end of the polynomial. The constant should be the y-intercept, and it is in this case. That negative 20 is the y-intercept. Now, how do you come up with the vertex? How are we going to come up with that vertex there? Kat, are you going to answer that? If you plug in any of those x's, what are you going to get? If you plug in -10, what should you get? For y? 0. Okay. So what are you talking about plugging in? Just randomly? Okay. Like what? Okay. Let's plug in -5. What happens if we plug in -5? If you plug in -5, look at what I'm doing at the very top. You would get 5 and -7, right? So 5, -35. Oh, wait, you said -5 though, right? You said -5. Plug in a -5. Yeah, that's right. It'll be positive 37 though. Right? Why would it be a 35? Did I miss something here? No. All right, let's look at this. That gives us a positive. I'm doing that right, correct? If I plug in a negative. No, that's not right. I knew something's wrong there. Okay, I plugged in a -5, and I got 5 times -7, which is a positive, which is a -35. That's right. 5 times a -7. So let's go ahead and plot that. -1, 2, 3, 4, 5, and down to 35. So there would be 24, 28, 32, somewhere about right here. Okay, we're going to call that -5, -35. Okay, so you want to try another one? What you want to do? What would you try now? Give me another one. You said -5. That's getting close, don't you think? Would you go to -6 or would you go to maybe -4? Okay, let's try -4. If we plug in -4, -4 plus 10, and -4 minus 2, what is that? 6 times -6, which is -36. So we'd have 4 and then -36. All right. What else do one want to do? It's still going down that way. right? What else would we do? Since you've already done -5, you're not going to go to -6, are you? What about -3? Let's do -3. -3. If we plug in -3, we get what? Over here. -3 is going to be our x, so that's going to be 7 times -5. Is that right? -5? Why are you going? Oh, I know why. That's why. Let me go back here to, what was it? -5? So that's -35. Does that help us? Yeah, that's perfect, right? That tells us exactly where our vertex is going to be. Now, it should be a little bit more fatter and rounder than that, but it should be something rounded like that. So what is our vertex then? -4, -36. That's our vertex. How do you know that's your vertex? Yeah. Okay, so that's our minimum. Yeah. What changes? Let's talk about it in terms of in behavior. Or let's talk about it in terms of behavior. What happens here? From -infinity to -4, what's happening? When x is at from -infinity all the way to -4, what's happening? Correct. And then from -4 to +infinity, it's going to be, so it is, your vertex is where your end behaviors change, right? It's where your behavior of your parabola changes, right? So you need to definitely be able to find your X-intercepts, Y-intercepts. Those should be easy. We should be able to find those really easy, right? Then, what are we going to find an easy way to find our vertex? Is there an easier way to find our vertex here? Cat says to find to make it easier, Cat says do -10, what? How are you going to find it? Oh, we're not going to count in between each one. What are we going to do? We're going to do the absolute value of -10 minus the absolute value of 2 and divide by 2. That's halfway in between, right? What's 10 minus 2? 8. Divided by 2 is? So that's going to be what? Actually, be -4. Ooh, we can't do the absolute value then. You're wrong. Yeah, you would just count over 4 from there. Yeah, count over 4 from there, and you would get, no, you wouldn't. 1, 2, 3, 4. Why is that not right? Should I have just said, oh, gosh, I don't know what I'm thinking. Mr. Anderson's not thinking right. We don't have to do absolute value. Why not do absolute value? What was I thinking of? No, let's just do negative, oh my goodness, negative 10. We're trying to find the average, crazies. All you got to do is add them up, divide by 2, because there's 2 points. Negative 10 plus 2 is negative 8 over 2. That is negative 4. Don't make it, hey, keep it simple, students. Don't be crazy. All right? So, now that you have negative 4, what are you going to do? We found negative 4. That's an X. So what do? Plug it in, and we would get our Y. Good job. So if we do negative 4, we already know that we're going to get negative 36. Now,